Hello बच्चों, let's read this question. So the question says calculate the mass of mercury which can be liberated from mercury oxide at 27 degrees Celsius by the treatment of excess of mercury oxide with 45.4 kilojoule of heat at constant pressure and constant volume, and given that delta HF naught of mercury oxide in solid state is minus 90.8 kilojoule per mole and mass of mercury is 200.6 gram per mole. This is the molar mass of mercury. So let us solve this question, and here the key concept is enthalpy of formation. Enthalpy of formation. So यहाँ पर हमें enthalpy of formation की वैल्यू दी गई है for mercuric oxide in solid state. So the equation representing that will be this mercury liquid plus oxygen 1/2 O2 in gaseous state gives us HgO solid, और इसके लिए delta H is equal to minus 90.8 किलोजूल पर मोल. बट हमें पूछा गया है कि how much mass of mercury will be liberated from HgO अगर हम उसमें 45.4 kilojoule of heat apply करें. So we are basically applying heat to mercuric oxide. So we have to revert this equation, and this will be HgO solid gives Hg liquid plus 1/2 O2, and for this delta H is equal to, ये जो साइन है ये रिवर्स हो जाएगी, so 90.8 kilojoule per mole. All right, so this is the value, and now we have to calculate the mass of mercury at constant pressure and at constant volume. So at constant pressure, mass of mercury is equal to heat applied divided by the heat of reaction, that is delta HR multiplied by molar mass of mercury. Alright, so यहाँ पर जो heat applied है that will be equal to delta H, because at constant pressure delta H is equal to delta H of reaction. Alright, so this is 45.4 kilojoule, 45.4 kilojoule divided by 90.8 kilojoule multiplied by mass of mercury is 200.6 ग्राम पर मोल. So इसको अगर हम divide करें, then this will be 1/2, and if we divide this by 2, then here we'll be having 100.3. So the mass of mercury at constant pressure will be 100.3 grams. Now let us calculate for constant volume. So at constant volume, we know at constant volume the heat change will be the change in internal energy. That means delta H is equal to delta U of reaction, and that is equal to delta H of reaction minus delta N RT, and this is delta N gaseous. So यहाँ पर ये जो delta Ng है, that is the change in number of gaseous moles in the reaction. Now here we can see that delta Ng will be product side में gaseous product सिर्फ एक ही है, that is oxygen, and that the coefficient is half, so 1/2 minus 0, क्योंकि reactant side में कोई भी gaseous reactant नहीं है, so this is 1/2. alright, so इसको अगर हम यहाँ पर calculate करें, then this will be 90.8 minus delta Ng is 1/2 multiplied by R, that is 8.314 joule Kelvin inverse, mole inverse, multiplied by temperature. Now यहाँ पर temperature given है 27 degree Celsius. So temperature will be 27 plus 273 Kelvin, which is equal to 300 Kelvin. So this multiplied by 300 Kelvin. And यहाँ पर जो है इसको हम किलो जूल में एक्सप्रेस कर रहे हैं. So here this will be divided by 1000. And we have to subtract this, and this value is 90.8 minus 1.247, 1.247, and this value is equal to 89.56, 89.56 kilojoules. Alright, and हमें delta H की value मिल गई. So mass of Hg will be heat applied divided by heat of reaction. That is, heat applied is 45.4 kilojoules divided by heat applied, that is 89.56 kilojoule, which is the heat of reaction. 89.56 multiplied 89.56 kilojoule per mole multiplied by the mass of the molar mass of mercury, that is m of Hg. So अगर हम यहाँ पर values put करें, 45.4 divided by 89.56 multiplied by 200.6, and this will be equal to 101.68 grams. So if we conclude, then the mass of mercury at constant pressure, so we can write it like this: mass of mercury at constant pressure is 100.3 grams, and mass of mercury at constant volume is 101.68 grams. This is the required answer, and I hope you understood the concept well. Best of luck.